We're going to look at this video at roots of polynomials and how we can find roots of polynomials or use roots of polynomials to go work back and find the original expression. So it says in this video a quadratic equation of the form ax squared plus bx plus c equals 0, where a, b, and c are real constants, can have two real roots, one repeated real root, or two complex roots. Now complex numbers we have not come across just yet, but don't worry, it doesn't really come up that often in this. It says if the roots of this equation are alpha and beta, you can determine the relationship between the coefficients of the terms in the quadratic equation and the values of alpha and beta. So if you just imagine here, you've got ax squared plus bx plus c, and what they have done is pulled out an a, and then they have factorized. So they pulled out a, which was a coefficient of x, so it is now just a x squared expression, and then you have x minus alpha and x minus beta. So if you imagine you had like a could be 7, so it could be 7 upon x minus 2, x plus 5, and this thing would have the two roots would be alpha, which would be equal to 2, and beta, which would be equal to minus 5. So it's just a two solution of things. So normally you'd say x equals 2 and x equals minus 5, but the roots really are 2 and minus 5. So if that is the case, then you can say if you expand that expression out again, then you get this thing. Now remember, this thing here is equivalent to ax squared plus bx plus c. So the coefficient of the x, let's just look at it first. Coefficient of the x was minus a upon alpha plus beta, but the coefficient of the x here is b. So b is equal to minus a upon alpha plus beta. And we'll see how that we can use that in a minute. And also the coefficient of x to the 0, or else the numerical term, is just c, and over here it's a alpha beta. So basically you've got that b is equal to minus a upon alpha plus beta, and c is equal to a times alpha beta. Okay, what we need to understand then is this, that if alpha and beta are the roots of the equation ax squared plus bx plus c equals 0, then alpha plus beta is equal to, so these are the two roots, the sum of the roots is equal to minus b over a. So we'll just write that in, sum of the roots is equal to minus b over a. And the same idea, alpha plus beta, so that's the two roots multiplied together, is equal to c over a. So the product of the roots is equal to c over a. Okay, I've just written down one that we all know, so we can just look at this to just see that this does work. If you imagine this one, if you have this equation, I should say, x squared minus 7x plus 12, if you factorize this thing, it would factorize to be x minus 3, x minus 4 equals 0. So the roots would be x equals 3 and x equals 4. So you could say that alpha, one of the roots, is 3, and beta, the other root, is equal to 4. Now if we just separate this off, if you just look at them and see if this does work, alpha plus beta would be equal to 7. So that means alpha plus beta equals minus b over a. And let's just see why that is, because b itself is minus 7, a is 1. So minus 7 is just 7 divided by 1, which gives you 7. So it does work. Let's just check with the products. Alpha beta is just going to be equal to 3 times 4, which equals 12, and that should be equal to c over a. C is 12, a is 1, 12 over 1 is 12, so it does work. Okay, next bit of note says the sum of the roots is minus b over a, and the product of roots is c over a. We've said about that. Note that these values are real even if the roots are complex, because the sum or product of the complex pair is real. Okay, again, we don't need to worry about that just yet, but that is, you just have to assume that's true. But after we've done the complex questions, then you'd be able to look at these and look at any complex ones that there are. Okay, let's go on to our first example. So it says in this example, the roots of a quadratic equation, 2x squared minus 5x minus 4 equals 0, are alpha and beta. Without solving the equation, find the values of alpha plus beta, and then alpha beta, and then 1 over alpha, 1 over beta, and then alpha squared plus beta squared. Okay, so we're not allowed to solve. It would be easy if we could just find what the two solutions are, and then we could just find these things dead easy. So, but we're going to have to do this a slightly different way. So A, first of all, alpha plus beta, let's just write down what, well, first of all, we're going to write down what our coefficients are. So A is equal to 2, B is equal to minus 5, and C is equal to minus 4. Alpha plus beta, from what we've just talked about earlier on, alpha plus beta is equal to minus B over A. So in this case, minus B is minus 5, so just 5 over A, which is 5 over 2. Done. Part B, we want to find alpha beta. Alpha beta then is just from what we've done earlier on, is just C over A. So C over A is just going to be minus 4 over my A, which is 2, which is minus 2. And my C. C, this is where it gets a wee bit weird. And a lot of these questions, they really just seem like wee puzzle questions. So you just have to really rearrange and figure out how on earth can you find 1 over alpha plus 1 over beta. That's what we're looking for. So in this question, you just go, if you have an algebraic fraction to this, your first port of call would be to take a common denominator. So the common denominator would be alpha beta. And the top line would become, that's just going to become beta plus alpha. And then if you write it that way, you have got alpha plus beta. You've already worked out what alpha plus beta is. And you've got alpha beta. You've already worked out what that is. So from here on in, it's just substitution. So from part A of this question, you knew that was going to be equal to 5 over 2. And I'll just write that as it was. So 5 over 2. And the bottom line is going to be equal to minus 2. So 5 over 2 divided by another 2 is going to be 5, or minus 5, I should say, over 4. Okay, part D. Part D, you've got to find alpha squared plus beta squared. Now this is a useful wee trick that I'm going to do here. So that's what we're looking for. Alpha squared plus beta squared. If you imagine I squared out alpha plus beta, what I would get would be, I'll just do this here, I'll do this out here, it's going to be alpha squared plus 2 alpha beta plus beta squared. So what I would need to do is take away my 2 alpha beta term. So I'll take that away up here as well. So that's now correct. So alpha squared plus beta squared is equal to brackets alpha plus beta all squared, then minus 2 alpha beta. And you can see why that is. So then we can just work that out. So we can get rid of that line. We don't actually need that line in. And we can just say what it is. And so alpha plus beta, we worked it out earlier on. It was 5 over 2, and that's squared. And then minus 2 times my alpha beta, wherever it was minus 2. And if we work that out, that's going to be 25 over 4 minus 2, which is going to be plus 4. 25, we're running out of space here, 25 over 4 is going to be 6 1/4 plus 4, which is just going to be 10 1/4, and that's it. Okay, here we've got that very useful wee thing which we used in part D of the last example, which was alpha plus beta all squared is equal to alpha squared plus beta squared minus 2 alpha beta. Therefore, alpha squared plus beta squared is equal to brackets alpha plus beta squared minus 2 alpha beta. So remember that comes in very useful for you in these questions. Okay, and this example says the roots of a quadratic equation are alpha and beta. Find the values of A, B, and C. So in this case, they tell you what alpha and beta are. So having a clue. So let's get started and see what we've got. We'll just write down what we have. We've got alpha is equal to minus 3 over 2, and we've got beta is equal to 5 over 4. So first of all, alpha plus beta, let's work out what alpha plus beta is going to be. It's minus 3 over 2 plus 4 over 5. So that's just going to be, minus 6 over 4 plus 5 over 4. So it's going to be minus 1/4 for my alpha plus beta, which tells me, remember, alpha plus beta is equal to minus b over a. So minus b over a is equal to minus 1 over 4. Okay, so we're already some way there to doing this question. Okay, let's look at alpha beta. So the product of our roots then is equal to minus 3 over 2 times 5 over 4, which is going to be minus 15 over 8. Okay, so that tells me that c over a is also equal to minus 15 over 8. So you've got your minus b over a, you've got your c over a. All I'm going to do here is put, this is my way of doing it, it's not necessarily the quickest way, but it's a simple way, I think, to do it. So I'm just going to always put a equal to 1, and then you can adjust at the end if it's not too pretty. So I'm going to put a equal to 1, which therefore means that your minus b is equal to minus a quarter, which means b is equal to a quarter. And also that means c is equal to minus 15 over 8. Okay, so you've got a few values. So the equation, and this is a perfectly acceptable equation, but it's maybe not nice. So we'll say, so far I've got my a is equal to 1, so it's now going to be x squared for ax squared. My b then is going to be a quarter, so a quarter x, and my c then is a minus 15 over 8 equals 0. Okay, read the question. It says find integer values for a, b, and c. So in this case, this is not going to be correct. But what I could do is just times through by 8. So times everything by 8, and you're just going to get 8x squared plus 2x minus 15 is equal to 0. And that's a nice easy way of getting your answer. And that's it. Okay, how you could check this is right, folks. You could do this out, find the two solutions of this, the two roots, and then add the two roots, and the sum of the roots then, find the two roots, and you should get, these are your two roots, so minus 3 over 2 and 5 over 4. Okay, you're now ready to do exercise 4a, and I will put in our own notes exactly what questions I want you to do. I don't think I want you to do the whole exercise 4a, so please just check and see what I want.